Okay, we're picking up P514 with the handle, and so just like any of the other revolves, we can kind of do the sphere, but it's a little bit of a challenge to get a good result with the dome. Or I'm gonna say, from a reliability standpoint, I would rather cut this in half and draw, pretty much that cross section and revolve it, rather than having to go back through the process. So I am making sure that I'm in metric this time. They're drawing it on the horizontal again, so we'll do center line, horizontal, infinite length. Place that on the origin. I would like to have my base, and we don't really know what that base size is. We only know the radius of the dome. So if I go over to center point arc, I know it's going to be somewhere on the center line, and we can start back there. If it doesn't go the way I want, I'm just going to keep going around. All right, so we go to 30 on the radius and 26 from the origin to the center, and then that will give us our size. All right, so L on the keyboard puts me into line, and I'm going to go ahead and close this one off. We will revolve cut, or revolve boss base 360 degrees. I was actually thinking about whether I wanted to include that 12 millimeter, but we haven't used the whole wizard yet, and the whole wizard will generate the drill point for us. So we're going to be in ANSI inch. We're in ANSI inch. We need to be in ANSI metric. Watch out for the dowel holes. In the drawings, it generates that little target shape. And while it's not too terrible to deal with, it's probably not as desirable as picking a standard drill size. So in the metric, we're going to scroll down until we get to the 12 millimeter. It didn't really give us a depth, so just kind of eyeballing that. We're going to go blind, and as a general rule, the minimum would be for the diameter. If I can go to the shoulder the same number as the diameter, 12 millimeters, we would also be able to go back and see what that post was, I think at 10 millimeters or whatever. We'd want to make sure that there's enough clearance there as well, that um, we're not creating a collision where the face doesn't seat. And if it's a press fit, this will be one of the places where we would look at a tolerance, because the manufacturing press fits have challenges, so that we would want to, and we already have a post handle, so I would probably call this more of a knob, or the base. So, all right, so we're ready to start our assembly. And assembly is not going to matter if it's inch or metric. So let's go ahead and insert our first component, and that will be the box. And because we drew it at the origin, and I'm pretty happy with its orientation and the way that it's being shown, I'm not going to rotate it, not going to worry about floating. We haven't had to float too many of these, but just keep in mind, if it, for some reason, you drew it in a different orientation, or you drew this part first and then added this, maybe it's rotated 90 degrees. It's not that critical at this point. We're just looking to create the geometry. So inserting the components for the post handle, we'll get that in place. And I'm looking for the pivot to actually occur there. Now, once again, I could do math, but we do have a method to center. So under the mates, and we can go to the advanced, and we'll have a width. So we need two faces, not necessarily that one, two faces on the same part. So inside, on one, outsides on the other, and that will keep it centered on the part. So once again, that was width, and the constraint is centered. They added that a couple versions ago, so I haven't played with that. Dimension, percentage, if you wanted to offset it, then there's other parameters there. So that constrains now 5 degrees of freedom. We still have the rotation. And because I don't want this moving unexpectedly, I would, let's see, is there going to be a spot where it's going to be easier to assemble? I'm going to go with the 90 degree then. All right, so with the post handle, if I do the flyout and look at the top plane and the right plane, those should be coincident. Let's see, did it go ahead? Yeah, top plane, and we need to be back in standard. And I would rather those be parallel so that it's easy to identify. And when we start to do like a limit dimension or an angle, then we could go back and possibly create a configuration or suppress the parallel and put in an angle. All right, so I'm going to hover over the box and hit tab. That hides it. Shift and tab shows it. So if I can locate it or I haven't moved the mouse too much, I can always come back over to the property or the tree and be able to hide and show from there as well. All right, so the link we're going to place and center, and that one went oh, that makes sense. It's tangent because I picked a planar. So between the two holes and this one has the little bit wider, so it's 6 millimeters, 7 millimeters, 276 to the 4 millimeters. So let's go with the width one more time. I'm going to go into Mate, select the Advanced tab, go to Width, and then pick two faces on one part. And then we'll pick two faces on the other part. Now, if you want to do the math, it's really not that complicated of math, but the problem is going to arise that we decide that this gap is too much and we need to make a change, and then the part doesn't stay centered. This will stay centered regardless of our process. So let's see, this was in fact 10 millimeters. What is left on the post link? So it's able to rotate that way. So when I see the minus sign, I would like this to be pretty much stationary. So if this was able to rotate the top plane of the part, well, those aren't going to be coincident anyway, so we'll go with parallel again. All right. At this point, the pivot box, let's do the shift tab. So I'm just going to hover in this general area and shift tab will show. Or again, I can come over and right click. The one we don't use as much here is to expand and come out to hide and show from that list as well. So the display settings and some of the other things will start to work into our strategies. Inserting the component then, we'll grab the handle and we'll go concentric or coincident since I grabbed the planar faces, and then the cylindrical faces, concentric, and when I look for it, we'll lock the rotation. All right, so if you drew the pins, you're going to insert the pin here and here and put those in place. If we're going to the toolbox, we have a 6x14 and a 6x26. So that's an interesting choice considering that we ended up with, okay, so it's going to be a little bit wider. So the 16 and the 520, okay. So on the toolbox, under the design library, we come over to the task pane and expand out at the toolbox. And if it's not added in, if I'm doing a lot of assembly, I'll go up and have it launch with the software. And the one thing I do notice that when it's local like this, it launches a lot faster. We share our toolbox across the network, then it takes a little bit longer for it to find that find all of those paths. All right, so I'm looking for pins, and we're in ANSI inch, or no, we need to be in actually in ANSI metric, and we're looking for pins, and we have coil spring, spring pin. I thought that they would have had a standard standard pin. Okay, so since the pin isn't there, we'll go down to the DIN standard, which is German, I believe. We'll go to those pins, parallel pin, same as a dowel pin in the ANSI. Do we need it to be hard because it's a pivot? Yeah, we probably do. So let's go ahead and drag one in. No matching size. So we're going to go with the M6 and see if we can find a matching length. So there is the by 26, and we'll go ahead and accept it. All right, so since it didn't snap, there it snapped. So if you get it to snap, came in so big that I don't know that we would have been able to pick, but I always call those the stack of marshmallows. If you get the stack of marshmallows, that'll at least give you concentricity. All right, since it's not there, we'll go concentric. And let's just see what it looks like if we go coincident. And that did end up being 26. I was doing the 16. Yeah, okay. I'm still trying to do that math in my head apparently. All right, so that one would be okay if we did change the length because this is going to be able to move around quite a bit. Then we would have to edit that geometry. So since I'm looking at this, let's go ahead and expand this out. We'll lock the rotation. And then the other thing of note that is if I did happen to pick a 24 millimeter, I can edit the toolbox components. That puts me back in this window to where I can change the size without having to delete it and reinsert it. All right, so I will go this route. That one's a little closer. So there's my stack of marshmallows. It is an M6, and this one is going to be by 14, so that's already there. We'll go ahead and accept it. I don't need another one. And we'll go coincident. And that gives us the assembly. So one of theirs is vertical like this. The other one is kind of this way. Oh, let's go ahead and shift tab our block back in. All right, so the other thing with the toolbox then is this is going to mount to something. So optionally, what I would be interested in for our metric hardware, we'll go to nuts, bolts, and screws. Let's just see if we can find a hex. Those are probably going to be pretty good size. So sometimes we're just going to pick. That wasn't too bad. So that went to a 5/16 24 for the 8 millimeter. I'm not sure why I don't think well, I probably drug it over from inch. Yeah, my inch was expanded, so it found the closest. So we'll make sure we're in the correct standard. Let's go to the hex, formed. Don't remember all of the standards, but let's go with a hex bolt. There we go. So it goes to an M6. That is quite a bit of tolerance for for positional, and if this thing is going to be operating back and forth, I'm not sure that I want that much. And 30 is the smallest on that one, so we're just putting it in for reference. The other thing would be if I wanted to add a washer for the, for example, then we would scroll down, we'll find plane. Let's go with a regular flat, put it in place. See if it runs into anything, which is usually the primary concern. And then we can go back to our the hex head, and that was a 2.3.5. So I would like to be consistent on my selection, M6 by 30. Okay, so if I did need data washer over here, I could suppress the mate, reapply the mate, put in the washer, and have that geometry. So why don't we go ahead and do that. So the first hex bolt, I'm looking for this coincident, and if I suppress that, it's going to allow that to move. And just like our other components, that was nice of it, but where did it go? Okay, so it did grab coincident there. And that was the mate reference assigned in that washer, so we will we'll take that. And what I was looking for then, since it kicked that out, let's see if we can find the other coincident. All right, so there's the one that I suppressed. So if I edit that first, we can clear out those selections, and then I would just change it over to the washer. Once it's selected, then it shows up as the grayed out. We can unsuppress it, and that puts it into place. All right, so examples of how to work with that geometry. Let's go ahead and do our exploded view since we're thinking about it and getting ready to go into the drawing. So I would like to do the hardware first, and as a general rule, the hardware does go in last. I'm not sure about that selection, but let's see if we can pick on the auto spacing a different direction. So I'm in inch, so 1 inch should be okay. Oh, and I jumped out of it, so rather than starting a new exploded view, I want to go over to my configurations tab, expand those out, and we'll just edit the feature. All right, so I would like this one and its pin. So since I don't see that 14 millimeter pin, we can go ahead and pick it from the flyout, and then those will move that way. Probably not the most descriptive, but we'll click the done, and then that one, and the handle I can see. Let's go ahead and get the those in there, and we'll see if we can stretch or shrink that auto spacing and make it look a little bit better. And then we'll go back to 1 inch there as well. All right, so I have something that is workable. All right, so the other thing I would be interested in is collision. So let's go ahead and double click on the exploded view. I'm going to add a configuration that is dynamic. I want to see this move. So I mentioned the parallel, at least on the first. So that one's for the link. It should remain parallel. I don't want it flopping around. So if I suppress that parallel, and we had, and then we have the angle that we can put in its place. All right, so if I go to the right plane and we find the post handle, expand this out just a little bit, maybe a little bit more so I can see the, Yeah, I was hoping to be able to see the arrows over here. So the right plane and the top plane, we're going to set an angle. Now, if I go to a limit angle, I would need to know where it collides. What are the limits of its movement? So from a position, it is able to go from there. So if that's my starting point, we'll see what it generates. But I need to know on the move, if I do a collision detection, where does it run into the groove over here. So we'll switch that to collision detection. These components should be just that and that. When I resume the drag, it will stop. And it always, especially the volume's up, it makes the noise and makes me jump. So let's go to the top plane, and might as well do the top plane of the assembly. And I'm looking for the measure tool, so we'll go into evaluate and measure, and it's about 42, so I should be able to get 45 degrees without any real issues. So if I bring that over close to there, I'm going to try not to put any negative numbers. So if it's in this position, this would be a negative 90, this would be a positive 45, or some combination. If it does anything weird when it's moving, then it's usually because of those selections. So I want the top plane and the top plane of the handles. So that went from 0, or it went to parallel. I would like to have that be an angle, but that one's just going to set for the direction. So we need to go find, not in the mechanical, in the advanced, then we're going to see that other button that we got on the right menu, context. So that is its current position. I want the max to be 135 and the min to be 0. And we'll go ahead and accept that and see what it gives me. So it should stop or not. So sort of, but let's go the other way. Okay, so we need to get back into the angle, edit the feature, and I'm looking at this and going, let's, if we flip the mate angle, well, that's a little bit closer, but we have a collision, so no, not a desirable result. So let's select that one more time. We'll go into the mate, and then let's flip the dimension. So we have those combinations with the limit dimension and the limit angle, and we're going to check and make sure that it's giving us a desired result. All right, so if I didn't make this parallel, it's going to kind of go in position, and since this pin is vertical, whatever it's driving is going to have to kind of keep this parallel as well. So this is going to allow me to make an alternate in the drawing if I want to. So P5-14 pivot, and we'll save the assembly there.